Hello everyone, I hope you and your families are safe and well. Welcome to another lesson. Today's title is Set Notation and Venn Diagrams. And just before we get started, I'm going to recap last week's lesson where the title was Introduction to Probability. We covered combinatorics slash product rule. Then we covered theoretical and experimental probability. And then we talked about mutually exclusive and independent events. So if these terms are not familiar to you, then please make sure you go back to that RL05 lesson to ensure you understand what these terms mean and you understand how to answer some questions related to these terms. Now I would like you to pause this video and have a go at answering the two starter questions. And when you have finished, then press play and you will see me going through the answers. So we're going to answer it one by one. Here we have question 1. A bag contains beads that are either red, blue or green. Work out the probability picking a blue bead out of a bag. So I would highlight this. I'm going to underline it because it's just easier for me. But if it was on paper, I would highlight this information. We need to work out the probability. So it looks like a simple-ish question. However, we have 5x and 4x. So we know that the probabilities have to add up to 1. And so I'm going to write 0.25 plus 5x plus 4x equals 1. So 0.25 plus 9x equals 1. Subtract 0.25 from both sides. We have 9x equals 0.75. And so x equals 0.75 divided by 9. Let me just work that out using a calculator. So if we type this into a calculator, we get 0.083 recurring. Picking a blue bead out of a bag, the probability is 5x. So I'm going to write 5x. 5 multiplied by this answer here gives us 0.416 recurring. And 4 multiplied by x is 0.3 recurring. Moving on to question 2. On the final night of a school trip to London, the students were asked what they would like for their evening meal, their meal choices and relative frequency. So this is something you'd highlight. Of each is stated below. Pizza Cottage 0.4, Daz's Fish and Chips 0.5. Okay, so here it says Burger Queen 0.1 is the probability of a person choosing Burger Queen as their favorite place to have a meal. And there are 16 people who chose Burger Queen. So how many people are on the school trip in total? Well, we haven't been given the number of people who prefer Pizza Cottage and the fish and chip shop. However, we're going to use the information we have regarding Burger Queen. So 16 people opted for Burger Queen. That represents a tenth of a total. So we have to do 16 multiplied by 10 to get 160 as our total. That's how many people were on the trip overall. How many chose Pizza Cottage? Alright, so now we just do 160 multiplied by 0.4. And how many chose Daz's Fish and Chips? 160 multiplied by 0.5. So this is 80. And this is divided by... Let me just use a calculator to make sure I'm correct. Yeah, okay. 64. Okay, so today's lesson, we're continuing with probability, of course. And I'm just going to tick off the subtopics which we have already covered. Now, last week, when I delivered the lesson on probability, I said that we're going to touch on some of these things. So we did touch on this one, on here, mutually exclusive, independent. However, we're going to look at it in more depth today, and you will see it in our next lesson as well. So that's why I actually don't particularly like using the checklist for probability. We will be covering a number of these subtopics over the course of several lessons. It's not like conditional probability, we're going to do it all in one lesson. And then move on and never talk about it again. That's why I don't really think it's beneficial to just tick off a particular subtopic and cross it off. Of course, today we're going to do Venn diagrams, but you will see that we're going to involve some of these other ideas like mutually exclusive and independent events. They're all quite linked together. So I actually think it's more beneficial to look at Maths Made Easy's list of subtopics within the probability topic. And we have covered the basics. We've covered scatter graphs. Of course, today we will do Venn diagrams. Today we will cover set notation. We have covered stratified sampling. We have started with relative frequency. Of course, we will talk about it again. And is that it? Yeah, there's another Venn diagrams here. So today we are covering Venn diagrams and set notation, but you will see references to some of the things we learnt last week. So I would like you guys to write some of this information in your books. We're talking about sets. The definition of a set is a collection of objects named elements. And so a set can be defined by listing the elements between braces. Now, braces is these, which they're kind of like brackets, but curly brackets, if that makes sense. And so here we have a set. It includes the 5 elements, 1, 2, 3, 4, and 5. Okay, so if something is an element of a set, we use this symbol. So it's kind of like an E. If something is not an element, we use the same E, but then we draw a line through it to say it's not an element. So for example, in this set, we can say that 2 is an element within A, and 89 is clearly not within those braces, so we can say that 89 is not an element in A. If a set has no elements, it is called an empty set, and it's just written as this. The universal set is the set of all elements being considered, and it is written using this symbol. The union of two sets, A and B, is the elements in A or B, or in both. It is written like this. A, this is kind of like or, so it means A or B. So yeah, that actually means union. So union means A or B. The intersection of two sets, A and B, is the elements that are in A and B. It is written like this. And this means and. A and B. Okay, example 1. We have a set A and another set, B, and it says that epsilon is all the numbers from 1 to 20. Find A and B. So A and B are the values which are in both sets. So let's circle them here. So I'm just highlighting the numbers which are in both sets. These two. So I can write 3, 5, 7, 11, 13, 17, 19. Find A or B. So that would just be listing all the values. So 1, 2, 3, there's no 4 in either. So all the values which are in either of these sets. 15, 17, 19. What would a Venn diagram look like? So here is here are two Venn diagrams. The first one, the highlighted region represents A union B, so A or B. Here, and that would mean it's just in A. It could be here, which means it's just in B. But if it's in here, it means it's in the region which is the intersection of A and B. So the intersection of A and B is represented by this middle region, and it just means that the data set is within this highlighted, shaded region. Now, on the top left Venn diagram, you can see that we've shaded in everywhere outside of A. So this is represented by this symbol. This means the complement of A. So the complement of A, in other words, just not A. The data point can be anywhere on the Venn diagram as long as it's outside of A. Now on the next one, we have a region which is defined as A and not B. A would have been highlighting everything, right? But we're saying it has to be in A and it cannot be in B. So that's why it says A and not B. A and not B. Okay, so before I go through example 2, please make sure you've drawn those Venn diagrams in your book and you have made a note of all the key information thus far in this lesson. Example 2 is a question whereby they've given us a Venn diagram. It shows the number of people who like Pepsi Max and Coke Zero. So P stands for Pepsi, so I'm assuming it's this circle, and C stands for Coke, of course, Coke Zero. Find the probability that the person likes Pepsi. So I'm going to draw a circle here. How many people like Pepsi? 36 people. 36. What is our total? So it's 36 plus 2, 38, plus this, that would be 47. So that's the probability of our first, of how many people, that's the probability of people who like Pepsi. Find PUC. I always think it's useful to highlight the Venn diagram. So PUC means P or C. So I'm going to draw a region which represents that. 36 plus 2 is 38. 38 over 47. Then we have P and not C. So this is P, right? And it cannot be C, so we cannot highlight the shaded, sorry, we cannot highlight the intersection. So this is the intersection. We cannot highlight it. So it's just 31 out of 47. Alright, so here we have example 3. You could try to answer this by yourself. If not, just continue playing the video and just watch how I answer it and make notes. Find the probability of A, so 0.5. Now, okay, on this question it's slightly different. We don't need to divide by anything because the probabilities have already been given. If you look at these 4 values, they add up to 1, and so probability of A is 0.5 plus 0.1. We don't actually need to divide by the total number of people or anything like that. So this equals 0.6, of course. Probability of, okay, so part E is not A and not B. So let me just use a different color. Not A and not B is going to be represented by this orange region. So it means everywhere outside those 2 circles. So the probability is simply 0.2. Probability that it's not A and it's B. So it can't be A and it has to be B. So it's going to be this region, right? So it's just 0.2. Now, part D, it says, are A and B independent? Now, remember last lesson, we said that if A and B are independent, then... Actually, I don't think we mentioned this. If A and B are independent, then the outcome of one event doesn't affect the probability of the other. And so probability A multiplied by probability of B is the same as probability of A and B. So actually, yeah, we did mention it. Please make a note of this information in the yellow box, and yeah, we'll move on in a sec. Example 4, we have to draw a Venn diagram. So use the information to draw a Venn diagram. Okay, let's do that. Okay, my intersection is too small, I think, but yeah, I'm hoping that is alright. 0.05. Now, the probability of A is 0.25. And so to work out what goes into this region here, we have to do 0.25, take away 0.05. That gives us 0.2. So, all right, 0.2. And the probability of B is 0.6. So we have to do 0.6, take away the probability of the intersected region. And that gives us 0.55. Right, what do they add up to? So 0.25, 0.80, so there should be a 0.2 here. They all add up to 1 now. So we've drawn a Venn diagram. Find A or B. I'll use a color I haven't used. A or B. So A or B would be this whole region. So instead of adding them up, I could just do 1 take away 0.2. 1 take away 0.2 is 0.8. find the probability that it's not A and it's B. So not A and it's B. Okay. So B is going to be this one, right? So I cannot highlight the shaded region. And so it's just going to be 0.55. Are A and B mutually exclusive? So if A and B are mutually exclusive, then the events cannot happen at the same time. So in this case, they are not mutually exclusive because probability of A and B is not 0. Probability of A and B is 0.05. So please make a note of this information here. And also we could write that when A and B are mutually exclusive, probability of A plus the probability of B equals the probability of A or B. And I'm actually going to show you what the Venn diagram would look like. So we have a Venn diagram, and the only real difference would be that we have two sets, A and B, and there's no intersection. And so when there's no intersection, we're saying that probability of A and B is 0 because it doesn't exist. Look, there's no intersection, it doesn't exist. There's no probability for it. So I would like you to pause this video right now and have a go at matching each diagram to the given set notation. So there are 8 diagrams. You could number them, you could draw them out. I recommend drawing them all out so that you it's there in your book. But if you have drawn quite a few Venn diagrams already, then feel free to just number them and maybe write A, B, C, D, E, F, G, so E, F, G, H. So yeah, please pause this video right now, have a go at matching these up. So we're going to go through the answers now. Please make changes if you got some of them incorrect. Please feel free to ask me questions if you don't understand any of them. I'll try my best to explain it to you. So the Venn diagram below shows what some people had for breakfast. C is the event that they had cereal, and T is the event that they had tea. So find the probability that it's not C. So not C means it's everywhere outside of this circle. And so we have to add these two up. So it'll be 46 over what do we have in total? So 46 plus 19 is 65. Oh, it's out of 100, so that's convenient. Simplifying the fraction as well. Find the probability that it's C and it's not T. C and not T. So that's going to be this region, this green region here. So I'm going to write 19 over 100. For part C, it says find the probability that it's not C or it's not T. Now that or is really important. So there are a few possibilities. One is that it's not T or not C. So I'm going to circle that 4. It definitely cannot be in this intersected region, because that is C and T. It's not C, but here it says not C or not T. So we could have a situation where it's just C or just T. And so we're going to add those probabilities up. I think that's correct. Did it in my head, 46. Yeah, I think that's right. We could simplify it as well. Conditional probability. Now, you probably saw that on the checklist. Here is one of the topics where we're going to start talking about it. Given that questions in Venn diagrams narrow down the number of possible outcomes to just this part of the Venn diagram, we're looking at an example of a given that question. So when you see given that in a particular question, you know that you're going to be working with conditional probabilities, because they're giving us a condition at the end of the day. Given that a person had cereal, what is the probability that they didn't have tea? So you are only selecting from those who had cereal. So it's saying given that they've had cereal, what is the probability that they didn't have tea? So now our entire sample space is just out of 54, because we're disregarding those people who didn't have cereal. So of the 54 people, 19 of them did not have tea, because look, this 35 did have tea. And so the answer, the probability, is 19 over 54. We can now apply all this knowledge to a free set Venn diagram. So here is an example of one. 75 boys were asked which football team they were a part of. Football, rugby or cricket. Of course, some are a part of all three. Some were a part of two of those. And this is a Venn diagram to show their responses. So I'm going to go through the questions one by one. Again, you could answer these by yourself if you want to challenge yourself, but if not, just go through it with me, and then you'll have an opportunity to do some independently as well. Find the probability that a student selected at random played football. So we're just going to add up the probabilities, numbers in this football circle. So we're not actually bothered whether they've just played football, they've played football, cricket and rugby. We're just focused on whether they've played football. 12 plus 5, 17, plus this, 19, 20. Find the probability. So it's 20 over 75. And again, please simplify this in a question. I'm not going to bother doing it right now, because I'm just focusing on answering these questions. You guys know how to simplify fractions. So yeah, I'd like you to do that. Played at least one of the sports. Okay, so played at least one of the sports. So that's everyone who is within these three circles, right? I always think it's useful to go back to the Venn diagram, highlight it, use a different color if you have a different color. But yeah, it makes it so much easier in my opinion. Played at least one of the sports. So we could add these values up, but an easier way of doing it is doing 75 take away 35, and that would give us 45 over 75. Played rugby but not cricket. So they played rugby. So I'm going to circle this. I'm going to be very careful here because they cannot have played cricket. But we haven't mentioned football, so we'll include this part in our region. So 5 plus 6, 11 over 75. Didn't play football. So again, it would be the region outside that blue circle, which I highlighted a few minutes ago. And it would be easier to just do 1 take away 20 over 75. And that would give us 55 over 75. Played more than one sport. So I'll use red maybe. So which of these regions represent those individuals who've played more than one sport? So I'm going to do here. So it's going to look a bit like a flower, I guess. Right. Is 11, so I'll write 11 over 75. Given that a student played football, what is the probability they played another sport as well? So firstly, I'm going to underline this given that. I have essentially just been told that I'm answering a conditional probability question. Given that a student played football, so I'll just circle this right now. Sorry, that looks a bit messy. What is the probability that they played another sport as well? So given that they played football, what is the probability that they played another sport as well? Let's use black. That means these 3 regions within that big red football region. So 5 plus 2 plus 1 is 8. So it's going to be 8 over 20. Yeah, 8 over 20. So for part C, it says find the probability that a student played cricket given that they did not play rugby. Now, they've reworded it in such a way to maybe try to confuse us, but let me reword it in a way which makes more sense. Given that they did not play rugby, find the probability that a student played cricket. So this given that is really important. We're going to first write the number of students which did not play rugby. So 35. Essentially everything outside of this rugby circle, so 35 plus these values, so 24, 59, so it's going to be out of 59. Find the probability that a student played cricket. So out of these 59, how many students played cricket? This one and this one, so 12. Here is another example. It looks kind of similar to the previous example, so you could just do this independently. If so, pause the video. If you're still not too sure about these types of questions, then just listen to me go through it. 200 people were asked whether they have been on holiday in the past 5 years. This is the Venn diagram. So find the probability that a person selected at random has been to Europe. So add these values up. So it's 17, 40, 50, 152. I worked that out in my head, so I'm hoping I haven't made a mistake. Yeah, had been to exactly one of the 3 places. That's really important. Exactly one of the 3. It doesn't say at least one of the 3. Exactly one of the 3. This is something I'd underline if I saw that in an exam. So exactly one place, and exactly one place. Add these 3 values up and we get 132 over 200. Had been to none of the 3 places. So that's very simple. It's just 15. Had been to Europe but not Asia. So we'll come back to our Venn diagram. Europe but not Asia. So it's 135. Yeah, because we're adding these 2 values together. Given that, another conditional probability question, given that a person had been to the USA, what is the probability that they've also been to Europe and Asia? So we're going to circle the USA. So let me just add these up quickly. 20 plus 33 is 53. 53 plus this is 56. Plus this 60. So it's going to be out of 60. Europe and Asia. What is the probability that they've also been in Europe and Asia? Okay, so that would be... It might be better to use a different colour actually. This region here. These people, out of all the people who've been to the USA, these 3 groups have people who've also been to Europe and Asia. What Europe? Oh, sorry, Europe and Asia. So I was just working out Europe or Asia, but Europe and Asia is just this 4 here. It's just this one, because these guys haven't been to Asia, and these guys haven't been to Europe, so we have to circle this 4. I almost made a mistake on that question. Part C, find the probability that a person had been to Asia given that they have been to at least one of the places. So again, we're going to reverse this question. Given that they have been to one of the places, so let's first deal with that part of the question. At least one of the places. It doesn't say exactly one of the places, but at least one of the places is represented by this region consisting of these 3 circles. And so it will be easy to just do 200 take away 15, which is 185. Find the probability that a person had been to Asia. Now, with a different color pen, I'm going to underline the people who have been to Asia. So we don't care about Europe right now. So we're just focusing on seeing how many people have gone to Asia. So 13 plus 10 is 23, plus 3 is 26 plus this one is 30. Not too many actually. Oops, 30. Now I would like you to pause this video and have a go at answering these two questions. When you are ready to see the answers, press play. Please mark your answers. Also, if you have any questions, if anything does not make sense, please make sure you ask me to explain it to you. I can understand some of you getting confused on these questions, especially on question 2, because there is quite a lot of information to process. So after you complete this video, I would like you to answer at least 3 questions from the Maths Made Easy Venn diagrams worksheet. I'd like you to aim to do questions 6, 7 and 8. However, if you are finding them too difficult, there is no harm in doing some of the earlier, easier questions. Please also mark your work using the second link. And also, I would like you to watch the TikTok videos accessible through the links in the remote learning assignment on Teams. Take notes when I am going through the my turn questions and answer the your turn questions. You'll have to pause the videos several times, and so yeah, you can just do that by clicking on the screen. It's really important to do those TikTok to go through those TikTok videos as well, because they are questions which most GCSE math students tend to find difficult. So it's really important for us to get as much practice as we can on those types of questions. After you've done all your work, after you've completed the lesson, please scan or take a picture of all your work and submit it by clicking on Add Work and then clicking on Hand In. Now, it's a 2-hour lesson, so I would like you to complete these tasks, all of these tasks. On Thursday, our lesson will be a live lesson, hopefully, and it will start at 11:25. So please make sure you are on time. Please make sure you have caught up. You've completed today's lesson, completed the last few lessons as well. And remote assessment. So we will be doing a practice test next week. It's not confirmed, but it's highly likely that we will do it next week. If not next week, we will definitely do it sometime soon, maybe the week after. And it will be done remotely. And so I'm looking at a number of websites to see how we could do a remote assessment. And so that's why it's not fully confirmed yet. I'll speak to you guys more about it soon. I hope I will give you more information. I hope I'll be able to give you more information on Thursday's live lesson. And we're actually quite lucky because we're going to be doing a trial. We're going to be doing a trial practice test, and then there will be a whole year test. So everyone in your year group will be doing a remote assessment, hopefully. And it's just for us to see where you are right now, and to hopefully see evidence of some excellent work being done by you guys. As it says here, I will confirm arrangements on Thursday. A little homework reminder for you guys: please make sure you complete the Sparks task, which is due on Thursday. Complete any overdue tasks as well. Ask me questions, of course, if you're stuck. And I've mentioned this already, but please make sure you complete your overdue remote learning assignments. I have emailed some of you about it, so please make sure you check your emails. And I'm just going to come back to the previous slide. The practice test will likely be on topics which we have been doing recently during this lockdown period. So it's really important that you are fluent with these topics. And it's really important that you ask me for help if you are stuck. So yeah, that's it for today. Please make sure you complete the questions on the worksheet. And yeah, if you have any questions, then please contact me. If not, then take care and I'll speak to you next on Thursday.